Hey, welcome to week 4 of the class. Thanks for joining me. We're going to talk about ionic compounds in this chapter. And over here on the right is a periodic table. And normally I teach in a room and I run up to the periodic table and I say, what are all these elements on the left? And people normally say, hey, they're metals. And then I point to the right and I say, what are all these elements on the right? And we normally say they're nonmetals. And it turns out ionic compounds you get when you get reactions between metals and nonmetals. And we've talked about atoms, but we haven't talked about ions yet. So let me tell you a little bit about ions. So ions, Li is the element symbol for, do you remember? That's right, it's lithium. And lithium has a tendency to lose an electron. And if it loses an electron, it actually has a charge. Because it loses a negative charge, it actually ends up forming a positive charge. So I can go ahead and write the little plus in here. Now, lithium may lose one electron, but something like magnesium can actually cast off 2 electrons, and because it loses 2 negatives, then the overall thing left behind has 2 positive charges. So these things are called ions. So these are ions, and ions essentially are charged atoms, or molecules, or whatever. We'll just keep for charged atoms for short. Now, when they have a positive charge, we actually have a special name for them. We call them cations, and cations is the name we reserve just for ions that have a positive charge. And how do you remember the difference? Well, actually, the third letter reminds us that it has a positive charge in. That T there looks just like a plus, and so that's how we remember the difference between them. And you might say, well, what about difference? I didn't tell you the other one. So if you go to the right-hand side, those are what kind of elements? Yep, that's right, they're nonmetals, and so something like chlorine actually has a tendency to grab and pick up electrons and make a chlorine ion, and things like, something like nitrogen actually likes to grab onto 3 electrons, and it forms a nitrogen 3- ion here. So again, these things over here are ions, and they actually have a special name, and the name for these are anions. So anions are when they're negative, and the easiest way to remember, I think, is if you look at that third letter, it's a minus. So take a look, right? So the third letter here is a T, that looks like a plus, so that's cations, and here the third letter is a negative or an I, right? So anions are negative ions, cations are positive ions. So hopefully you can remember the difference now. Now, the thing about these ions that they come together and they form an ionic compound. So if we take the lithium ion, Li+, and we take the chlorine ion, Cl-, they come together and they form an ionic compound. And so we can see those opposite charges attract each other. The ionic compound, actually, we just write as LiCl. The charges cancel out, so they are not written. And we can see that the lithium has a 1 positive and the chlorine has a 1- charge, and together they are completely neutral. In fact, the golden rule, if you like, is that the charges have to cancel out. So charges must cancel in an ionic compound. So ionic compounds. So remember, compounds are things that are made from 2 or more elements, and the key thing here really is that the charges have to cancel out for an ionic compound. So that's LiCl for you. Now, if we look at another ionic compound, so if we look at magnesium, which actually has a 2 positive ion, and chlorine, which is a 1- ion, we can see the golden rule here is that the charges have to cancel. And if you take 1 magnesium and 1 chlorine, those charges do not cancel out, right? Because you got 2 positives here and you got 1- here. So if we write this right as plus plus and minus, you can see that the 1 plus and the 1- cancel, but the other plus, right, it doesn't have anything to cancel with. So we need a second chloride ion, or a chlorine ion, to get this to work. So the second chloride has a charge of 1-, and this gives us the second thing to cancel out. So I can go ahead and erase that question mark and draw the line up over here. So 1 magnesium requires 2 chlorine ions for the charges that completely cancel out, and if the charges completely cancel out, we've got an ionic compound. So here's how we write the formula. Since we got 1 magnesium, we write Mg. Since we got 2 chlorines, we write Cl, and we write a little 2 subscripted to the right. So this is the number of chlorines, and if there was more than 1 magnesium, we would write it right here. So this would be the number of magnesiums. And again, the golden rule, right? So this is the compound. The golden rule is the charges have to cancel. And we can see that there's only one way for them to cancel, and that is when one of these reacts and bonds with two of these. So we got MgCl2. Okay, we can look at a tricky one here. So magnesium, we saw, has a 2 positive charge, and nitrogen has a 3 negative. And if we want to figure out the compound, if we want to figure out how these come together so the charges cancel, we can do it a couple of different ways. And it turns out that the way we looked at just before was a little bit hard. You can see that the magnesium has only 2 positives, the nitrogen has 3 negatives, so you've got an extra minus here. So clearly we need another magnesium, right? So if we have another magnesium, let's see, that would be Mg2 plus right here. That would give us another couple of positives. And now we've got 4 positives and only 3 negatives. So darn it, the charges don't cancel out. So you might say, well, right, we take another nitrogen, and if we take another nitrogen, that's N3 minus. That brings on another 3 negatives right there. And now we can see that there's too many negatives. There's 6 minuses here, and there's only 4 positives here, so they don't cancel out. So gosh darn it, we need another magnesium. And if we have one more magnesium, then I think the charges are all going to cancel out. So we got, let's see, 1, 2, 3, 4, 5, 6 pluses, 1, 2, 3, 4, 5, 6 minuses. So for every plus, there's a minus. So we can write that as a formula. We can write Mg. There are how many of them? There are 1, 2, 3. So we write the 3 down as a subscript to the right. And there are 2 nitrogens. So there's an N, there's an N. So we write N2. So this would be the formula of the ionic compound. So this is a chemical formula, and notice for ionic compounds the charges in the naked ions, right, are written out, but when they come together they cancel out, so we don't ever write the charges in. And I said there's another way to do this, and there's another way to do this actually, and the only problem is there's one situation where it doesn't work, and let me show you how to do it quickly and when you have to worry about doing it quickly. And the quick way to do it, I think, is just kind of the swap down method, so you can take the charge and swap it down to the other side, except you just take the number part of it and you ignore the plus or the minus. And so we can write the chemical formula here by writing Mg3 and N2, so we've basically just taken the 3 minus down to a 3 and the 2 plus down to a 2, and we've kind of just crisscrossed them like that. So that's a much faster way to do it. And the only problem with that is that occasionally we run into something like this. So if we had Mg and we had, let's see, oxygen, which is a 2 minus, we could see that their charges cancel out when you just have one of each. So 2 pluses and 2 minuses give you neutral. So we really just need one of each. So we can just write Mg1O1 or just MgO for short. Now, if we did the crisscross method, right, we would take the 2 and the 2 minus, and the 2 plus, and that would give us Mg2O2. And so the only thing we got to remember is with the crisscross method, if we can simplify to a smaller set of whole numbers, then we do it. So 2 to 2 becomes 1 to 1, and so we have to always remember if we have a 2 to 2 or a 3 to 3 or a 4 to 4, it can all be simplified as 1 to 1. And if we had something like 4 to 2, it could be simplified as 2 to 1, let's say. So that's the easiest way to write formulas. Okay, here's one for you to try. So aluminum actually forms an ion with a 3 positive charge, and oxygen forms an ion with a 2 minus charge. And I wonder if you could pause this video for a second and figure out the formula of these. So go ahead and pause, figure it out, and let's compare notes. Okay, very good. So you're back. So the easiest way I would say to do this is just to crisscross them down. So take the 3 plus and make it a 3, and the 2 minus and make it a 2, and then you can just go ahead and write Al2O3. I'm going to put it in a box there because I think it looks neater and tidier. Now, what about the charges, you say? Well, the charges are no longer written in because they've canceled out. The golden rule is these things have to cancel out. Because they cancel out, they're no longer written in for the compound, even though for the naked ions we have written them out. So very good. If you got that, pat yourself on the back. If not, just replay it and see if you can get it a second time. All right, moving on.